Welcome to lecture 34 on file handling in Python. Files are objects, as is every programming entity that we have looked at so far in Python. And files happen to be the primary interface to all external files on a machine. So if we take our file explorer, we find that there are a number of folders, there are a number of files inside them. These files that we deal with, whether it be text files, audio files, video files, every file can be accessed using file handling mechanisms in Python. And the file handling mechanism in Python acts as the primary interface to all these files on a given machine. What we can do is we can read, we can write, we can append to a file, and we can work with these files seamlessly. All the files that we have stored in our machine are always available to us, provided we have the necessary permissions. And once we have a file which is available to us, we can handle that file, we can work with that file using the Python programming language. There's a small typo here. I'll make that change so it's everything. Yeah. So, having introduced files in Python, let's try to get into the operations one after the other. The first operation that we'll be looking at is creating a file or writing a file. Here, what we are trying to do is we are trying to open a file. The name of the file is data. The extension of the file is txt, meaning that this is a text file. It's important to note that whenever we are trying to open a file, we must specify not only the file name but also the file extension. And the file name and the file extension are separated using the dot. So on the left of the dot, if you observe, we have the file name, which is data, and on the right of the dot, we have the file extension, which is txt. And we also have to mention the operational mode or processing mode, which in this case is W. W is short for write. What we are trying to do through this entire statement that I have just highlighted, we are trying to open a file called data.txt, and we are trying to open this file using the write mode. Now, what will happen is if this file already exists in our current working directory, what is the current working directory? The current working directory is simply the path in which this particular notebook is running. That happens to be our current working directory, and we are trying to access this file data.txt in the current working directory itself. But here we have to be careful about two things. The first thing is, if the file does not exist in the current working directory, what will happen is the file will be created for us. And if the file already exists in the current working directory, it will be overwritten, and it will be overwritten by the content that we provide. How do we provide content to the file? The content that we want to write to the file? We provide content through the write method. So this fobj acts as a file pointer. So using fobj, we'll be able to access our file. And when we want to write to the file that we have just opened, what we have to do is we have to use the write method. And we can pass the string using the write method. And it's important to note that we can have multiple write statements. So here we have one call to the write function, we have a second call to the write function, and once we are done with the write operations, once we are satisfied with the contents that we have written to the file, what we can do is we can close the file. And in order to do that, we have the close function. So if I execute this, okay, before I execute this particular cell of code, let's look at the current working directory. This is our current working directory. And if we look at the current working directory, we do not find any file, any text file with the name data. So what will happen is when we execute this, the current cell, when we execute the current cell, what will happen is the file will get created for us, and it will be created with these two lines of text, the two lines of text that we are passing as strings to our write method. So let's execute this. The moment we execute this, and if we go back to the current working directory, we find that the file has been created for us. It's called data.txt, and as you can see, it was created seconds ago. It was just created. If we click on this file, there you have it. This is the content that we had written. So if you go back to the code, we have two lines that we have written: welcome to another video on Python programming, and we have appended a new line, and after that we have another line of text: hope you all are doing great. And both these lines have been successfully written to our file data.txt. So that is how we go about writing to a file. Let's go through the key takeaways. The open function is what we are going to use in order to access a file. So it will be our interface to any file. You do understand that before performing any operation on a file, whether it be a read operation, a write operation, or an append operation, the first thing that we have to do is we have to open that file. We have to set up a link between the file present on our secondary memory and a file pointer or a file pointer variable through which we'll be accessing that file. And that variable for the given example is fobj. So we'll be using the open function in order to establish a link between our Python statements and the actual file which exists on the secondary memory. Now the file name has to be provided, whether we are performing a read operation, write operation, or any file handling operation. The file name is a must. The processing mode is optional, but it is strongly recommended to provide the processing mode. So I would not leave it to the defaults. Whatever be the default processing mode, it's best not to rely on that default processing mode. Rather, explicitly specifying the processing mode will always be helpful in case of understanding the code that we are writing, and also in debugging the code in case any error arises. So processing code must be provided. This is a strong recommendation. And the fourth bullet point, we have already discussed that if the file does not exist in the current working directory, then it will be created for us, provided we are using the write mode. And if the file already exists, then what will happen is the existing file will get overwritten by our new file. So the file name will remain the same, but the content will change. And the last point that we need to understand is that, okay, let's go through the second last point first, that closing an already opened file is strongly recommended. This is a point that I made earlier as well, that we use the close function. We call the close function on our file object variable in order to close the file. This is strongly recommended, and we should not leave it to the Python environment to close the files for us, so that this guarantees that whatever changes we have made to the file, those changes are permanent. If we leave it to the Python environment, it may so happen that the contents that we have written may not get truly reflected in the file. So that was about creating or writing a file. Now let's try to see a modification of the write operation. Now, as you understand, we have the file currently present in our current working directory. So here it is. Once again, for your reference, it's called data.txt. And if we again try to open the file, this is the point we were just discussing. If we again try to open the file in write mode, what will happen? Because we are specifying only the name of the file, we want this file to be created in the current working directory. But in the current working directory, the file already exists. So what will happen? The existing file will get overwritten. And what will it get overwritten by? It will get overwritten by the content that we are providing. So the new line that we are providing here is Python programming is easy to grasp. What will happen is this file data.txt will now be recreated for us, and the content of the file will also change. It will now become only this single sentence, which is Python programming is easy to grasp. And lastly, we'll be closing the file. So let's try to execute this and see what happens. So we have executed it successfully. And if we open the file, there you have it. The contents have now been erased. And if you look at the modification time, it has been modified a few seconds ago. That means my file got recreated once again. So please remember that if you are using the right mode, the file always gets created in the current working directory. And please make sure that if you already have a file with that name, make sure that you do not use the same file name, because if you use the same file name as an existing file, and if your path of operation is the current working directory, then the existing file will get overwritten by the new file and the contents will also change. So if you do not want that, please make sure that you modify the path, which we are showing in the next example. So if you look at the third example here, once again we are trying to open the file, but this time around we are not specifying only the name of the file. You remember in the previous two examples, we only specified the name of the file, data.txt. Once again, in the second code snippet, we specify data.txt. When we specify only the name of the file, the current working directory is where the file gets created. The current working directory is where the Python environment looks for the file. But what we can do is, if we want to create multiple files having the same name but different content, we might as well specify the actual path. So instead of specifying only the file name data.txt, what we can do is we can specify the entire path. So if we specify the entire path, which in this case happens to be a folder within my D drive, then the existing file in the current working directory, which is also called data.txt, would not get overwritten. And here we can once again specify the contents through the write method. So again, we have two lines of text to write to our file. And lastly, we can close the file. So if we execute this, okay, before I show you the execution, if I go to this path, so this is the path that we are talking about. So if we look at this path, there is no file with the name data.txt. But if we try to execute this, once we execute this, you see a file comes into existence and it has just been created. It has just been created, and if you open this file, there you have it. Compare this with the contents that we have just written. If we compare this with the contents, you'll understand the point that I'm trying to make. You see, we may specify the path and append the file name at the end. No overwriting this time because the absolute path is different from the current working directory. So what just happened here? Instead of specifying only the file name and relying on the relative path, we relied on something known as the absolute path. So what is the absolute path? Absolute path is the entire path in which we want our file to exist. So this path that we are referring to, this path is with respect to the file hierarchy that we have in our system. So here on my laptop, I have a D drive partition. Under the D drive partition, I have a folder which is called my folder. Within the my folder, I have a subfolder called my subfolder. And within that my subfolder, I want to create this file data.txt. So this is how we provide the entire path. And when we provide the entire path, what we get is the absolute path name. An absolute path name is always a better option when we are dealing with files. Do not always rely on the current working directory where you specify only the name of the file in order to work with files. Remember, specifying only the name of the file would lead you to the current working directory, and specifying only the name of the file refers to a path known as a relative path. So we are more interested in absolute paths over relative paths because that helps to manage the files in a better way. And one more thing that I want you to take away from this particular code example is that the write method does not add a new line at the end of every text that it writes. So here you must have noticed that when we are having the first write method call, I have purposely appended a new line character. The reason for that is if we do not append this new line character, the first line, which is we may specify path and append the file name at the end, this line would get written, and then right next to it, without having any space or any new line, the next piece of text that we are trying to write would get appended to the file. So this is something that you would not want. For better representation, for ease of understanding of the contents of the file, we would want to append the new line character at the end of every line that we write to our file, because the write operation will not add a new line at the end of our text. So that takes care of the writing operation, the writing and the creation operation. In the next video, we'll take up the operation of reading a file. Hope you found this video useful, and if you have any doubts, please feel free to leave them in the comment section below. Thank you, and I'll see you in the next one.